Welcome back to Math 103. This is video number 10 on growth and finance. We're looking at a problem in which instead of putting money into a bank and earning interest on it, you are borrowing money and ultimately paying interest on it. In this example, you're borrowing money at 7% interest today, 7% annual interest is what that means, and you expect to be able to repay $20,000 10 years from now. How much can you afford to borrow now? Well, mathematically, this problem has exactly the same structure, exactly the same setup as the previous one about putting money into the bank, even though now you're borrowing and before you were saving. The mathematics, the setup, it's all the same. So we set up the compound interest formula, and what unknown are we looking for? Well, the present value. Whatever we borrow today, whatever debt we accumulate today, is going to grow by a certain factor every year for 10 years. And after 10 years worth of growth, our debt will turn from whatever it is today into $20,000 later on. So FV, the amount of our debt in the future, will be $20,000. PV, the amount we borrow now, is unknown. I, the interest rate, 0.07, so every year our debt grows by a factor of 1.07, that's the annual growth factor, the 1-year growth factor, and that's going to happen 10 separate times. So what we borrow today will be multiplied by 1.07 10 separate times. That's the same as being multiplied once by this 10-year growth factor, 1.967151357. So $20,000 equals the result of taking today's debt and multiplying by the 10-year growth factor. That turns out to equal $10,166.99. Another way to say it is that $10,166.99 is the amount today, which corresponds to $20,000 10 years from now, if the growth rate is 7% every year. If your debt grows by a factor of 1.07 every year for 10 years. So bottom line, this is how much you can borrow today, $10,166.99. So that means that the difference between the cash you get in hand today and the amount you pay back later, that's the interest. That difference is $9,833.01. You can think of this as the rent that you have to pay for the privilege of holding on to this money for 10 years. Right? So you get the $10,000 and change today, and what that costs you is $9,833.01. Right? This is the amount of profit that the bank is making off this transaction. That's another way to think about it. This is the fee that you are paying the bank for the privilege of getting this much cash now. But wait a minute, that means that the interest you end up paying is almost as much as the amount that you originally borrowed. Ouch! So if you're cringing while you read this example, that's because it really is painful to think about. Right? And that's why it's very important for you to understand this very practical topic. This is a crucial part of anyone's education. The examples we've just been looking at have involved either putting money into a bank and just letting it sit there without making any withdrawals, or borrowing a sum of money and not making any payments along the way, just waiting and making one big repayment at the end. Let's look back for a moment at putting money into the bank. Well, it's unrealistic to think that you're never going to make any withdrawals. So can we account for putting an initial amount into the bank and then making some withdrawals along the way, or perhaps even seeing changes in the interest rate that the bank pays along the way? Here's a specific example. Suppose you deposited $1,000 on New Year's Day 2015 in an account earning 3.5% APR, 3.5% annual compound interest, with interest credited to the account on December 31st of each year. Now consider what would happen if you withdrew $100 on January 1st of the following year, and then withdrew another $150 on January 1st of the year after that, but made no other withdrawals. How much money would there be in the account one more year after that, New Year's Day 2018? Now we can solve this, but but it's important to keep track of the account balance on each date when a change takes place, either a withdrawal or a payment of interest. Since you have money in the bank, interest payments are coming to you. That's money that you receive from the bank. On January 1st, 2015, the account starts out at $1,000. The account balance, that means there's $1,000 in the account. The next time something happens is December 31st of that year. The balance grows according to the interest payment. Whatever has been in the account all year long, that $1,000, grows by 3.5%. That's what it means the bank is paying interest once a year. So it's multiplied by the 1-year growth factor and grows into $1,035. The next time something interesting happens, the next time there's a change in the account balance, is actually the very next day. That's when we said that you make your first withdrawal, that you take $100 out of the account. So that's just a straightforward subtraction. You're down from $1,035 to $935 that day. But that $935 remains in the account all year long. It's that $935 which then has interest applied to it, a year's worth of interest applied to it. So that $935 is what's growing by a factor of 1.035. It ends up as $967.73. The next day, New Year's Day 2017, the story was that you take out another $150, right? So that's just reducing the account balance going into that day by $150. That leaves you with $817.73. That amount sits there in the bank all through 2017. That amount is what grows at the end of the year by a factor of 1.035. So at the end of that day, which is to say, again, the next day, on New Year's 2018, you have $846.35 in the bank. So we really needed to account for every single change in the account balance along the way. We could not take the original $1,000 and just multiply it by some overall growth factor. That's because we took money out along the way. As another example of changes along the way, where now it's the interest rate that changes over time, suppose that you deposited $1,500 on January 1st, 2010 in an account which paid 3.5% annual interest, credited to the account on the last day of each year. So same situation, however much money was in the account all year, receives a single interest payment of 3.5% at the end of that year. On January 1st, 2012, however, the interest rate increased to 4.75%. This happens over time, that interest rates change. Now try to answer the following question before going on to the next video. How much money was in the account on January 1st, 2015, assuming that you made no withdrawals? All that happened is you started with $1,500, it grew 3.5% a year for 2 years, and then it grew 4.75% a year for 3 more years.